All right, so what we're going to do today is we're going to go over the Intro to SQL programming assignment that you guys had. I'm going to go through that. So anybody who didn't turn that in, it's late. So, I haven't decided whether I'll give any points to any assignments that are turned in after today. But let's take a look at the assignment that we were supposed to do here, and I'm going to go through the various queries that do it. Okay, so the first one was to find out how many domestic migrations were there in 2013 in each of the areas of the state of New Jersey, sorted by FIPS number. And in order to do that, like all our things, all our problems here, the first thing you need to know is what tables you need in order to figure that out. So I'm going to create a new query here. And the tables I need, I look at the fields that are in the output here. The fields that are output are FIPS num, area, state, metric name, metric year, and metric value. So FIPS num, area, and state are available in geographic area, in the geographic area table, that we built in our first assignment. Metric name, metric year, and metric value are available in the population metrics table, which we also built in our first assignment. So, the tables that we need. So first of all, we'll type our select command here. The fields that we need are exactly those fields that were in the assignment. So what I've just done is I cut and paste those from the assignment description right into here. Okay, we're going to have to, work with this a little bit, but this is a good start. These are the fields that we need. And I specify that directly in the assignment. The next thing we have to figure out is what tables those fields are in. And as I said, FIPS num, area, and state are in geographic area. And we can look here, right here in our database. We see FIPS num, state, and area. And if we look at our population metrics table, we'll see that has metric year, metric name, metric year, and metric value. So the two tables that we need for this are geographic area and population metrics. So we'll put those in the front. The next thing we need is the join clause. How are these tables joined together? So we can put that in a where statement. I'll do it another way in just a moment. But the join clause here is the geographic FIPS number, geographic area FIPS number. Has to equal the population metrics FIPS number. That's our join clause. And then we need our select predicates. And if we look at the assignment, it says the metric year or the year should be 2013. And we're looking at the state of New Jersey. Okay. So that's our query. But it says, question also says, we want to sort that by FIPS num. Okay, well, we'll put FIPS num here. Now we realize here, since we have two FIPS nums, for any place we have FIPS num, we have to make it clear which FIPS num we're using. Whether it's the value from geographic area or the value from population metrics. So what I'm going to do is I'm going to make it clear that this FIPS num here is the geographic area one. And so is this one. Even though they're equal, we have to say which one we want. So that's the query. That's the whole query. And I could have done this another way. Sometimes it's nice to separate the, to use the join statement instead of where and then just leave the where for the select predicate. So I could have done it this way as well, and as long as I didn't make any major mistakes here. Oh, wait, I did make a major mistake here. I said domestic migrations. The metric name is domestic migrations. I forgot an and clause here in my predicate here. There we go. So I realized that, and I now have my query, and here we have the domestic migrations for New Jersey in 2013. That was query one. Any questions on that? So once again, when we think about our relational algebra, which is how we started this class, these are the project fields. These are the relations that we're joining. These are the joins. This is the join predicate. This is the select predicate. And then we got to sort to it. Anybody have any questions on this? I think a lot of you got this one right. This one was one of the easier ones in the homework, and that's how you do it. Okay. So that's number one. Let's look at the second one. The second one says alphabetically list all distinct metric names in the population metrics table. And the only field we need here is metric names. So the field we need, you have to tell what field we need. We need metric names. Now, the other thing it says is we want the distinct metric names. So if you remember for select, we had this keyword distinct. So we're going to select the distinct metric names. Now, what tables do we need to get the metric names? Well, there's only one, population metrics. That's it. That's the only one we need. And the next question, or the next part of the set of the question said alphabetically. So alphabetically means order by and that's the whole query. That was number two. Let's run it, make sure I did it right. Metric name, sorry. There you go. There we go. And there's the result, the metric name. So, some of you, I think added additional tables here and things like that. You really don't need those additional tables. You look at the field, and as long as you don't need other fields beyond what's being projected, if you don't need any other fields for the predicate, you just stick to the one table and keep it simple. When you add more tables, you run into trouble. So that's where some of you ran into trouble was you thought you needed joins here. You don't need to join. This is a one table query. So that was number two. Any questions or comments on that? Okay, let's do number three. Find the number of births in 2017 for any area that begins with the letter C, sorted by Phipps num. All right, so once again, I'm just going to copy my fields that I need here. I'm going to create a new query. I'm going to select those fields. Interestingly enough, they're very similar to the fields we had in the first query. So that tells me I probably need the same tables. Give me 1 second. So I probably need the same tables, geographic area and population metrics. we'll do this the join way because. So, we could have even just copied the other query. We know we needed this on geographic area. We need the join predicate, if num equals all right. Now we need to worry about what the select predicate is. Let's look at what the thing says. It says the metric name is births. The year is 2017 rather. And the area begins with the letter C. So we can do that left to right. And the area name, find something that begins with the letter C, we put like C%. And that should be it. If I wrote that correctly. Yep. I remembered to do that in the first one, but I forgot to do it in this one. Oh, I forgot to order this also. Well, let's do that. Geographic area. Ipsum. And does it say how to order it? Sorted by Ipsum. Okay, so we forgot our order statement here, so we have to put an order statement there because it says how we want it sorted. And once again, geographic area. And there we go. All right, does anybody have any questions on this part?
Yeah, so the join, instead of adding a where clause for the equals, you just on, and then you just add the where to, what you're actually doing, like what you want it to be like against.
Yeah, I mean, I could have just as well have just had a comma here and had a where and had an and here.
So if you,
And I would have gotten the same result.
okay, so if you have the join, the, on would replace the where and the and would replace, the where would replace the and.
That's right, that's right. And the only reason why you might, I like using the join, like that's an inner join. So, these queries are equivalent for inner joins. If you're going to do an outer join or a left join or a right join, you need the word join instead of the comma. But if you're doing just an inner join, this is an alternative for the syntax for doing an inner join.
This is only, the comma is only useful for just regular joins.
Just for regular joins, yeah, inner joins. Okay, so I could have done either one of these and I would have gotten, you would have gotten full credit for either one of these. Some people, this is partly my fault, so I didn't take off too much for this. But some people got confused by the fact that, we still had that population data table lying around. That's the table we use to build these tables. So some people use population data table and did some weird things with that. And if you did that, I didn't penalize you too much, but that table was simply to load the database. It shouldn't have been used for any of these queries. Okay. And certainly you didn't need population metrics. You didn't need to include all three tables because that just made things complicated. The other thing I should mention is what happens, okay, who can tell me what happens if we don't include the join predicate? Does anybody know what happens if we don't include the join predicate? You remember in relational algebra, we learned about the cross product, which basically took every combination of all the records in one relation with every combination of all the records in the other relation. This is a mistake to truly avoid in database, because when you accidentally do a cross product, if you've got a very large database, you're gonna seriously tax that database. That query is never gonna end. So you're essentially, generating a very large number of records that you really don't need. So it's very important to keep in mind that you need a joint predicate, because you need to say how the records from one relation are going to be correlated with the records from another relation. And so that's an important thing that I want to make sure I emphasize here. And maybe I didn't emphasize it enough, but the joint predicate is very essential when you're putting together two relations or two tables, because that tells how they're going to match or how they're going to be correlated. Otherwise, you're just going to get a cross product. Any questions on that? Okay, so that was number 3. Now we get into some of the fun ones. Actually, yeah. Okay, number 4, find all areas in geographic area that don't have a rural-urban continuum code. So, this one I might have confused you a little bit, and if I did, I accepted multiple answers for this one. But the easiest thing to do here, you will build a new query here. Once again, I gave you these fields. I thought that was a real shortcut, but not really. So, okay, so we'll copy these fields again, because we're going to use them in our select statement. Okay. So if you look at this, you would say, well, I've got area, state, and rural. I have HIPS number, area, state, and rural, urban-rural continuum code. All of those are fields in geographic area. So the easiest thing to say would be, this is wrong. This is the wrong name here. This should have been rural urban continuum code. Should have been the name of the field. So you could have done this and just changed that and just made this from geographic area. And that, I obviously would have graded that correctly. And this says where rural urban continuum code is null. So the condition here would have been where not equals is null, ordered by sorted by FIPS number. So order by FIPS num. And in this case, we only have one table here, so FIPS num is unambiguous. And this query would have yielded, sorry, I selected, there we go. And this query would have yielded the right results. What this would have told us is that the things that are in geographic area that have null, rural, urban, continuum codes are the United States and the states rather than the individual areas. So, that's what this query does, is it tells you, these are the things that don't have a rural, urban code, and they're all states and the country. So, that was the easiest solution. But, if you took me literally, which is okay, and you thought this needed to be RUCC, oops. If you thought this needed to be RUCC 2013, one of you did something very clever, I thought. They said, as RUCC 2013. That's all they did. And then when they output this, you get the right name for the column. If you did that, I thought, yeah, really clever, full credit. That's great. That's great. That was one way people solved the ambiguity that I left in here. And this was Absolutely correct as well. Okay. Another way people might have resolved this ambiguity join is they might have done a left join. Yeah, they might have done a left join with rural urban continuum codes. On rural urban continuum code equals RUCC 2013. And where and then they could have gotten rid of this. This would have been another solution to the problem of the ambiguity of rural urban continuum code versus RUCC 2013. And if you ran this, assuming I didn't make any mistakes here, you would have gotten exactly the same answer. So any one of those three queries was perfectly reasonable and would have gotten full credit for this assignment. Does anybody have any questions on this? Now, this one is fine. I didn't expect you to know left joins for this assignment, and you didn't need it to do this particular query. But if you wanted to do that, and you did that, I certainly would have given you credit as well. Okay. All right. I'm going to leave this one up for a minute because we're going to do. No, we don't need that for next. All right. We'll need it for number 6, maybe. All right, so we'll do number 5 now. It says find the pop estimate for 2011 for all geographic areas that do not have a rural urban continuum code sorted by state. And the fields we need are these fields here. So let's copy those. I'm showing you the lazy man's way to write SQL from this assignment. I copy and paste as much as I can. So I put my select there, and these are the fields I need. And I see that these fields are in geographic area and population metrics. Once again. Yeah, my goal in this assignment was not for you not to have to know the join syntax, so this was part of the introductory SQL. We learned the join after that, but if you used the join syntax, that was fine as well. But once again, these things are related on geographic area.fipsnum. Equals population metrics.fipsnum. That's our joint predicate. And now what we need is we need our where predicate and our select predicate rather. And it says pop estimate is the metric name, 2011 is the year, and rural urban continuum code has to be empty or null. So let's capture that. The year is 2011. And rural urban continuum code is null. Now, some of you got confused by the language. It says that do not have a rural urban continuum code. And when they saw the not, they thought that meant not null. Double negative here, yeah.
It's not mine for this one. I got points taken off when I did have it as null.
Okay, I'll double check. If I graded it wrong, I'll update it. Right, yeah. Send me an email, Zach, and I'll check that for you. That might have been my mistake. All right. And if you do this, you get a total population, you actually get a total population estimate for each of the major areas, anything that's not a county, essentially the states and the United States. So, this gives us a total population for 2011 for each of these areas. And that's what this query is designed to do. If we were writing the description of this query, we would say, give total population for 2011 for these different areas. Okay, and I had to order this, by the way. I forgot to order this. This should be ordered by state, right? So let's rerun that. And this would have been the answer to that query. Or that piece, that was number 5. Anybody have any questions on this? Okay, I'm going to leave this one up because we're going to look at number 6 now. And one of the things is, what do you notice about queries 5 and 6? So we're going to leave number 5 up. And we're going to do number 6. Once again, I copy the fields. And actually, a lot of query 6 is going to look a lot like query 5. We're going to select these same things. Do that. Let's just copy query 5 into query 6 here. This part is going to be exactly the same. Fields are the same. Yep, fields are the same. So this part is going to be exactly the same between query 5 and query 6, but now we need our join predicates, our select predicates for query 6. And we look at the assignment and it says, pop estimate is the metric name, 2011 is the year, but this time we want the rural urban continuum code to not be null. But we can copy this almost exactly again. And instead of is null, we'll change this to is not null. And we'll run this. Oops. And we'll run this. And let me make sure. Yep. Oh, sum. Okay, I'm sorry. We're finding the sum. So let's find the sum. If we sum metric value, we're doing the sum there. What do we need at the bottom of this if we're doing a sum? What is a sum? A sum is what kind of function? Anybody remember? Yeah. Yeah, it's an aggregate function. That means it combines values from multiple records. Whenever you have an aggregate function, anything that you're selecting that is not an aggregate function needs to be in the group by statement. Something either needs to be the aggregate, and if you have an aggregate function, you either need to be an aggregate function in that select statement, or you need to group by the things that are not an aggregate function. So we add that group by the number 6, and we run this query. And we look at this query, these are the results of the query. By the way, you'll notice that when we do a sum, it says no column name. It's always good to, give it a name as pop, something like that. It's always good to give the column a name. So we look at this query and the output of that query, and we look at the output of query 5.
Oh yeah, I was gonna say, I forget what you said earlier. Isn't an aggregate function just when they have like a sum or something like that?
Yeah, sum or an average or count, anything that looks at multiple records to figure out what the value is.
So an aggregate function is just like basically like math aids.
Yeah.
essentially.
But the main thing is it needs multiple records. Okay, because there are math functions that you can do on a single record that will just do things across the fields of that record.
Oh, I see. So it's like adding all of this stuff together from the metric values.
That's right. So when we look at these two things, we notice that they're pretty much the same. They come out with the same values. So when we add up the things that are not null, they wind up being the same as the things that are null. The records of the things that are null. And why is that? You know, given that this is census data, well, the things that are not null are all the things that are not states or not countries. So what we're doing is we're adding up the total population of all the counties in New Jersey. You know, Ocean County, Monmouth County, Morris County, we're adding all those up. And we're finding out that, you know, the total of all those counties is the same as what they put in the database for the state. So it's a good way of validating the data. You know, we're checking to make sure we get the same answer, whether we have look at the aggregate value that they provided in the census data, or if we look at the component counties that make up that aggregate value. Does everybody understand me? Are there any questions? I always say that. Are there any questions on these two queries? Okay, so that's one check I kind of subtly asked you to do. And then we get to 6B. It says, find out the total US population by all years sorted by metric year. So what we're going to do is we're going to copy query 6. And we're going to create a new query, and we're going to edit this so that we do all the years. And we want the total US population. So we're going to get rid of the year clause here. And we're going to leave, we want the pop estimate. We want it grouped by state, ordered by state. And in this case, and oh, sorry. Let's see what I'm missing here. If I added this, I got rid of the year. Wait, let me double check the sorted by metric. Oh yeah, I gotta get rid of the state field here. There we go. State field should not be in here. There we go. That's ordered by, we ordered by. Sorted by metric here. Yeah, there we go. All right, so yeah, so in this case, the things that are not null are the individual areas, you know, the counties essentially. So what we're getting here is we're adding up all of the individual counties, and we get a total population count for the United States, because the United States is made up of all the counties in New Jersey, all the counties in Connecticut, all the counties in New York, you know, all the counties in all the states. So we get a sum total of anything where the rural urban continuum code is not null. That means anything that's not a state or the United States. Okay, so that query shows the population of the United States in 2010 to be about 313 million people, and so on for the other years. So that's query 6B. And then 6C says, write a new query to get the population estimate by year where the area equals the United States. So let's do that. You know, once again, I can copy this query. And I'm going to create a new query. I'm going to paste this query into here. Here it's not saying anything about urban-rural continuum. It just says area equals United States. So, you know, that's our new metric. And we don't need the aggregate function anymore because we're just looking at the United States. So we can get rid of that. And then we run this query, and hopefully I did it right. Yeah, we get a total population estimate for the United States this way. So we're looking at these two, and we notice that these are almost the same, but not quite. You know, this one says that the population for the United States is 309,321,000, and the other one says 313 million. The other one says 313,043,000. Does anybody have any theories on why these two might be different? Why do these two queries? Yeah, Nina. That's exactly right. Very good. I was trying to figure out when I ran this the first time. I'm like, why are these different? Well, the difference is the total United States population doesn't count the U.S. Virgin Islands. It doesn't count Puerto Rico. It doesn't count U.S. territories. So that's exactly what it was. Yeah. But, you know, if you didn't see this difference by doing this analysis, you wouldn't know, for example, that those territories are not counted in the total U.S. population that the census reports. Okay. Any questions on that? Or any comments? So when we add up the components, we got a higher total than if we just looked at the population of the United States that they put in the database.
Which one is that for?
That was for query. So query 6B gave us a higher total than query 6C. And then what we wanted to do is we want to add up just the states. So let's do that. Let's just do where the state is not equal to the US and where the rural urban continuum area is null. So once again, we can take one of our previous queries. It's query 5 in this case. So we'll copy this one. And we'll create a new query. You know, we want it for all years, so we're going to get rid of the year here. And we want to sum this for the states so that we get, you know, the sum population for the states. And if we sum it, we need a group by statement because we're using an aggregate function again. And we want to make sure we don't need state in here. We want to make sure that any fields that are not in an aggregate function have to be in the group by. And once again, we're going to order this by metric here. And we run this and we get, oops, oh, I forgot we're stating we're area not equal to US. We're stating not equal to US. And state not equal to US. There we go. And here we get the count again. And again, we get the higher count here because there are states here that are actually not really states at all, but are US territories. Okay. So, you know, we've got 3 different queries that essentially answered the same question in a different way. And 2 of them get the same answer and 1 of them gets a different answer. Okay. So, you know, if we're mining the census data, this is a result that we might get from the census data, is that when they aggregate, when they report on the total population of the United States, they don't include the outside territories. Any questions on these queries and how I got there? I know I went a little fast. The main thing I want you to take away from this, though, is the process. You know, again, we start with what fields we want. That's the project portion of the select statement. The next thing we decide is what joins we need to do. That is the from and the join portion of it. When we do a join, we have to include what the join predicate is. What are the fields we're joining those tables on? And we can do that with the on portion, or we can do that with, if it's an inner join, we can do it with the where as part of the where. And then the last thing is we have to specify what the criteria, what the selection criteria are that we're using. And that goes in the where statement. Okay. If we have an aggregate function, we have to do group by on any fields that are not an aggregate function. And if we want to sort, we have to do an order by to sort those fields, to sort by whatever field we choose to sort by. Does anybody have any questions or comments? All right, let's do the last one, by the way. We want to find any state in 2011 that had a population greater than 10 million. So we'll take this thing that finds our population by state, and we'll build a new query out of that. And we're going to add a predicate that says and metric value greater than 10. Make sure you get the right number of zeros. 6 zeros after the 10. 1, 2, 3, 4, 5, 6. That means 7 zeros total. Here. Oh, sorry. Okay. All right. This should be metric value. Here we go. Copy the wrong query. The is null. Okay. All right, did this one real quick. This is right. This is right. Pop estimate. Here's 2011. Is that what we want? Yeah. 2011. It's contained in an aggregate function. How many aggregate functions here? Oh, that's group by. That's what I did. There we go. Sorry about that. One more time. There we go. So here we find the states that have population greater than 10 million. And we've sorted by state. California is our biggest state. It has a population of 37 million people. New York, 19 million. Texas is bigger. Texas is bigger than New York. So, you know, if you guys were wondering what our biggest states are, there they are. And, you know, if we want to make this query completely accurate, we would leave out the U.S., but the U.S. appears here. But, you know, if you got these results, if you got California, Florida, Illinois, New York, Ohio, Pennsylvania, and Texas, you got full credit of this query also. Okay. Anybody have any questions on this last query?
I think I voted differently to add the sum and still, and I still got the right answer somehow.
Okay, and I give you full credit.
I was just saying, like, is that like
Yeah, there are a couple of the different queries you could have changed to get this answer. So yeah, absolutely. Okay. So that is the homework, or that was the homework. And, hopefully this is good practice for you, in thinking about how to structure these queries. You have to think about the different piece parts. Don't let that relational algebra lesson go to waste, because that'll be helpful for you in thinking about how to do these queries going forward. All right, so let me pause there. So you guys have an intermediate SQL assignment that you're doing now, and after that, you're going to have the advanced SQL assignments. So somebody asked me before class, is it going to be hard doing the Java program that goes with that advanced SQL assignment? The answer is no. You guys are doing a transaction as part of your intermediate SQL assignment. And all you guys are doing is editing the transaction that I put on Canvas, hopefully, and using that as the model for doing your transaction. It'll be the same thing with the Java program. I think the difference between your assignment and the Java program I give you is maybe, less than 10 lines. So don't start from scratch. The advice is don't start from scratch on those. Make sure that you use the example that I gave you, and it should be fairly easy for you, I hope. And if it's not, please make office hours with me and I'll see if I can point you in the right direction. All right, one other thing I wanted to do on advanced SQL before I quit that topic completely is I wanted to show you a little something here in the slides. I don't have a programming example for it, but I can give you one after. But, we did a transaction in SQL. And, we had the try and the catch and all that good stuff and the commit and the rollback. But you can write those transactions in Java also using some of the procedure calls there. Java already provides try and catch for you. And by default, anytime you do a SQL query, it will commit that SQL query by default. But the way you shut that off is you do an set auto commit on your connection to false. And then it will not commit the query until you do a commit, and you can do a rollback as well. So, you can do those transactions in Java, and you can use these library calls to turn off auto commit, to do the commit, and to do the rollback. And other than that, you just use the standard Java mechanisms for trying and catching and all that good stuff. Okay, so I did want to cover that as well. Yeah, these are. All right, and here's a link for you guys if you want to look, if you want to learn more about JDBC. There's a reference there. I'm covering it at a fairly high level and fairly quickly. But if you want to know more about JDBC, there's a nice tutorial online.
JDBC is the language like you add into Java.
JDBC is the libraries that are added to Java. Yeah. Okay. All right, so that's all I had today. What I'm going to do for you now is I'm going to give you the rest of the class time to get together with your group and talk about your group assignment that will be due at the end of the semester. So your near-term milestone for that group assignment is next week. I'm sorry, November 9th, the week after next, where you're going to have to select your data set and define your group roles and responsibilities. So I gave you some places where you can go for your data set. If you want to go with a different data set, as long as it's a good data set, you don't have to use one of the ones here, but these are the ones that I'll make available to you. In fact, I think I'll add another URL to this that gives you other alternative data sets as well. But you have to find your data set, and you have to figure out who's going to own each of these roles within your team. And the teams are, as we discussed the other week, and you guys should know by now, what team you're on and who's on your team. So take the remaining time for class to get together with your teammates and start talking about how you're going to do this project. You know, you might need to meet, you might need to have phone calls, you know, Microsoft team meetings, whatever you want to do to get together and work how this project gets done. All right, so I'm going to stop the recording there.